Alrighty, so we're going to look at concavity and what it means for curve sketching and talk about some, we probably already know a lot of this stuff, we're just putting some terms to what we are familiar with. So concavity describes how the rate of change changes. So the rate of change function is what? Derivative. So it's describing how a derivative function is changing, which means it is the derivative of our derivative or our double derivative. So anytime we see the word concavity, we're dealing with a problem that involves the double derivative. Cool? So to find out the concavity, all you need to do is simply derive it again, and then sub in our x values where we want to know. Cool? If our double derivative is greater than 0, it is concave up, like a cup. That's what a cup looks like for those of us who can't figure out. What does that mean? If it's concave up, it means we're dealing with if it's a stationary point, we're dealing with a minimum. Concave down, it's like a frown. And if we get concave down, we're dealing with, and 0 is a possible point of inflection. It may not be, but it's possibly a point of inflection. So if you need to check you've got a point of inflection, you would double derive it and let it equal 0 and find out when that occurs. Anything else? The first couple of questions will ask you to determine the range in which it is concave up and concave down. All we would have to do is double derive our function, and then if it's concave up, we'd have to let it be greater than 0, sub our function and solve for when that occurs. Does that make sense? So we'll be asked to do only two things with concavity. Number one, use concavity to help you sketch your function, so determine the nature of your max and your mins, or whether it's a point of inflection. Or you'll be asked to determine the domain in which it is concave up, concave down, etc. So if you're asked to determine the domain where it's concave up or concave down, you let f dash double dash x be greater than 0 and you solve for x. Sweet?
So what's it going to be if it's not inflection?
If it's not, it'll be like, so I can give you a function, for example, fx equals 4x, f dash x equals f double dash x. So that would be a situation where that's not a point of inflection. No matter what I shove in for x, it's going to be 0, correct?
Does that mean it doesn't pass that point though?
It's just saying that the straight line doesn't have the rate of change. Is the rate of change changing?
Yeah.
So that's why it's 0, not because it's a point of inflection.
Okay.
Sweet?
Yeah.
Cool, off you go.